All right, next we're going to learn a little bit about calculus and its application to business. This is very brief. So we're going to learn a little bit about it, do a few problems so that we're at least have like a passing understanding of it. So first we have revenue, cost, and profit. And revenue, they're typically going to talk about as R of X. Cost will be C of X. Profit will be P of X. Revenue is defined as how much X items brings in. So this is when you're selling the item before you take expenses into consideration. And the way that you calculate your revenue is you just do X, that's the number of items, multiplied by the price per item. Next, the cost is how much it costs to make X items. Profit is how much you make after expenses. So the profit is the revenue minus the cost. All right. Maximum profit, if you think in terms of curve sketching, if we wanted to find the maximum value of P of X, we would just need to find the derivative, right? So if we're thinking about the maximum of a curve, we'd find the derivative, set it equal to 0, make sure it switches from increasing to decreasing there. So same thing here. We're going to say take the derivative of the profit equation, set it equal to 0. So if we remember that derivatives have like the properties of derivatives, p prime of x equals 0 is the same as saying that r prime of x minus c prime of x equals 0, which is the same as when you look to see where the change in revenue is the same as the change in cost. So that's where your maximum profit is going to happen, right? When we do these questions, you just have to be very careful to pay attention to the wording of the problem to make sure that you're setting up the problem correctly. And aside from that, they're not too bad. So we have a manufacturer can sell X items a week for a revenue of 200X minus 0.01X squared cents. And it costs the cost is 50X plus 20,000 cents to make X items. Why are they in terms of cents? I don't know. Dollars makes a lot more sense to us, but these ones are in terms of cents. Is there a most profitable number of items to make each week? If so, find out what it is. All right, so I have R of X was given 200X minus 0.01X squared. The nice thing about this is that since they gave us R of X, we don't have to do the number of items multiplied by the price. Sometimes the way that they phrase the question, you're given a price and you have to multiply it by X, and that is the subtlety that students miss sometimes. All right, cost is 50X minus 20,000. And if we want to find the most profitable number of items, we're going to go ahead and find the derivative of R of X, the derivative of C of X, and we're going to subtract those or set them equal to each other. It doesn't matter. So R prime of X is 200 minus, and then if I do 2 multiplied by 0.01, I get 0.02x to the first power, so that part's good. C prime of x is just 50. All right, so I'm going to set them equal to each other. So negative 0.02x equals negative 150. I just subtracted the 200 over, divide by the negative. 150 divided by 0.02 is 7,500. All right. Now, In these cases, whenever there's only one number answer, you can pretty much be sure that that's your maximum. But remember, when you set the derivative equal to 0 and find the critical value, that's what we just did. We found the critical value. We didn't use this method. We did this, which is just an equivalent way of finding it. So we found the critical number, and technically we should do a number line or a sign chart just to make sure that it switches from positive to negative, that this is actually truly a maximum, not a minimum. And I'd say most of the time you're good. It would be a trick question basically if it didn't work out, but we can go ahead and plug it in anyway. Okay, so we're going to say revenue minus cost equals 0. We just want to make sure that that value is positive. So revenue minus cost. There's revenue, there's minus cost. We just want to make sure if we plug in a number that we get a positive and then plug in a negative. So I'm going to go ahead and plug in 0 because it's easy. So that would be gone. 200 minus 50 is 150. That's positive. If I do... well, actually, maybe instead of 8,000, I was just thinking something bigger than 7,500, but instead I'll just think of like the biggest number I can imagine, like 1,000,000 or something. Just make this a little bit easier on myself. 0.02 times 1,000,000 plus 200 minus 50 is definitely going to be a negative number. So there, I just did it without a calculator. Okay, so at 7,500, this switches from positive to negative. That means that it truly is a maximum. It's not a minimum, which is what we expected. So we're going to conclude in the context of the problem, the most profitable number of items to make each week is 7,500. All right. On the other side. Similar question, phrased a little bit differently. Given that the revenue is 10x and the cost is x to the third minus 6x squared plus 15x plus 5, where x represents thousands of units. So if you get x equals 1, that's 1,000. If x equals 2, that's 2,000, etc. Is there a production level that maximizes profit? If so, what is it? I'm going to do this one a little bit differently just so you have multiple examples in your notes. So I'm going to go ahead and say that P of x this time is R of x minus C of x. So we could do it exactly the same as we did the last problem. I just want to show another way of doing the same type of math, but just so you can see the steps a little bit differently if that's how you would have preferred to have seen it, or if it makes more sense maybe. So I'm just distributing that negative. I'll go ahead and combine like terms. Okay, so now I'm going to go ahead and find the derivative and set it equal to 0. And so to find my critical numbers, I need to solve this quadratic. So I can do the quadratic formula, I can do factoring. If I do factoring, I am looking for something that multiplies to positive 15 but adds to positive 12, and that's not possible. So that means this is a quadratic formula problem. So we've got negative 12 plus or minus 12 squared minus 4 times A times C divided by 2A. Negative 4 times positive 15 is negative 60. Too many minuses there. Negative, negative, negative. Just minus 60. Uh, 144 minus 60 is 84. You can simplify that or not simplify that, it doesn't really matter. So now if I think about doing my sign chart to see which one of these works, I've got 0, I can make, make nothing, or I can make infinitely many products. I'm going to go ahead and use a calculator for this just because we're going to have a hard time with those decimals if not. So, but if this was not calculator active, you'd have numbers that were a little bit easier to work with. Okay, so there's one answer. Okay, both of those are valid answers. They're both positive. If one of them was negative, I would have excluded it. Okay, so if I take my derivative and I plug in something smaller than 0.4, so I'm just going to go ahead and type out my derivative here first. This is a little calculator trick that I like to do. So I'm going to go ahead and take like 0.3 and store that as x. And then I can go back up here. Okay, so if I plug in 0.3, I get a negative answer. I'm going to go ahead and store 1 as x. Then if I plug in 1, I get positive 4. Bigger than 3.5, I'm going to plug 4 in as x. Negative 5. All right. So if I want to minimize my profit, this is what I'm going to go with. If I want to maximize my profit, this is what I'm going to go with. All right. So the production level that maximizes profit is 3.528 thousand units. So 3.5 thousand or 3,528 basically is what you've got there.